All right, guys, so I'm going to show you how to add and subtract rational expressions. And this section right here specifically for like bases or a like denominator. All right, so to add or subtract rational expressions with a common denominator, first, you're going to combine the numerators and keep the common denominator. Second, you're going to factor and simplify the remaining expression. All right, so if I'm working this out, let's go with this. We're going to go with, so I got x squared plus 5x minus 3x. So notice how they have common denominators right here and right here, common denominators. So I'm going to combine the numerators. Now this gives me x squared. So it's 5x minus 3x. So it's going to be x squared plus 2. Now this is going to be over 4x squared plus 5x minus 6. All right, but we could still simplify this. So in my numerator, I got x squared plus 2. So that's going to give me a, looks like a x, what could I factor out? Wait, x squared, oh, plus 2x. I could factor out an x, right? Now I'm left with x plus 2. That's in the numerator. I got to factor out my denominator now. So to do that, I notice that I have the 4, and this is an odd number. I'm going to factor by grouping, is what I'm going to do. So I'm going to rewrite it here. 4x squared plus 5x minus 6. So 4 times negative 6 is going to give me a negative 24. I'm going to bring down that 4x squared. And now I need two numbers that multiply to negative 24. But when I combine them, give me a positive 5. So this looks like it's going to be plus 8x minus 3x. And then I'm going to bring down that minus 6. All right, and now we're factoring by grouping. So I'm going to group this side. I'm going to group this side. So what could I take out? What could I factor out of this left side? 4x squared plus 8x. I'm going to take out the 4x. And now I'm left with x plus 2. Now I got to take out the right side. Looks like I take out a negative 3. And remember, they should both have x plus 2 inside the parenthesis. That's how factor by grouping works. So if I take out a negative 3, I'm left with x plus 2. And now both of these are the same. I know I did it right. So now I have 4x. I'm going to put this over here. So I'm going to have 4x minus 3 times x plus 2. And that's going to go in the denominator. So I have 4x minus 3 times x plus 2. All right. So we took care of that. Can I simplify? Can I get rid of anything? I can, right? I got x plus 2 in the numerator, x plus 2 in the denominator. Can I factor anything else out? I can't. That's all I got left over. So I got x over 4x minus 3. And that's my final answer. All right, so the rest of these aren't as complicated as that, but let's work them out. So look, common denominator. So when it's this simple, I'm just going to change this to n plus 3n all over 8. So now I have 4n over 8. We could still simplify, right? 4 over 8 is really just equal to 1 over 2. So now I'm not going to write down the 1. I'm just going to write down the n, but over 2. And that's my answer. Let's look at the next one. So just rewrite it if you have to. I got 7u minus 5u over 16. 7u minus 5u, that's going to give me a 2u over 16. 2 over 16 simplified is going to give me 1 over 8, or just u over 8. That's it for that one. To this one, same idea. Negative 8y squared plus 11y squared all over 3y. So negative 8 plus 11 is going to give me a positive 3. I'm going to have a y squared over 3y. 3 divided by 3 is just 1. Y squared divided by y to the first power is just going to be y. And that's it. Same thing for this one. So I got 5x plus 20 all over x plus 4. Well, I noticed this is not finished. I could factor that 5x plus 20. So what number could I take out? What goes into both 5x and 20? 5. So if I take out the 5, I'm left with x plus 4 over x plus 4. And now I got x plus 4 in both the numerator and denominator. So now I'm left with just 5. All right, number 9, same idea. So I'm going to have x minus 6 minus x minus 7 all over 2. So x minus x is 0. And then I got negative 6. So the x's cancel out. We'll just do this and do this. Then 6 minus 7, that's going to be a negative 1 over 2. And that's it for that one. Okay, I got, rewrite it, c squared minus 4 over c plus 2. Well, I could simplify this. I see this is perfect square binomial, so I'm just going to rewrite that. C minus 2 and c plus 2. All over c plus 2. Do they have anything in common? They do, right? So those cancel out, so now I have just c minus 2. All right. I have v plus 8 over v squared plus 5v minus 24. I know I got to factor out the denominator. So remember, two numbers that are going to multiply to give us a negative 24. But when we combine them, they give us a positive 5. So what numbers? Looks like it's going to be 8 and 3 somehow. Which one has to be positive and which one has to be negative? It looks like it's going to be positive 8 and negative 3. So I'm going to rewrite this in the numerator. I'm going with v plus 8 and v minus 3. So now, can we cancel anything? Right, we can. The v plus 8's cancel, and I'm left with 1 over v minus 3. That's my answer. All right, 15. 2r squared minus 4r all over r squared minus 12r plus 20. I could factor both the numerator and the denominator. So that's what I'm going to do first. In the numerator, what could I take out? Well, I know I could take out a 2. I could also take out an r. So when I take out a 2r, I'm left with r minus 2. In the denominator, now I'm looking for two numbers that are going to multiply 20, but combine to give me a negative 12. 10 and 2, right? So 10 and 2, and they have to combine to give me a negative 12. So it's got to be a negative 10 and a negative 2, right? Because negative 10 times negative 2 gives me a positive 20. Negative 10 plus a negative 2 gives me a negative 12. So I'm going to have r minus 10 and r minus 2. Can I simplify anything? I can, right? The r minus 2's, they cancel. And now I'm left with 2r over r minus 10. All right, looks like 17, we got multiple. So, oh, that's good. They all have the same denominator. So let's do this. I'm gonna go x squared plus 1 plus 5x minus 2x plus 11 all over, I could factor this x squared minus 4. So I have an x and an x, and it's going to be minus 2 and plus 2. All right, let's combine our like terms. The numerator. I'm going to have a x squared. I got 5x minus 2x, so x squared plus 3x. I got 1 plus 11, it's going to be plus 12. And this is still over x minus 2, x plus 2. All right, so let's factor this part out. So I'm going to keep that x minus 2 and x plus 2. Here's an x and here's an x. So two numbers that are multiplied at 12 but combined to give me a positive 3. 12, 6 and 2. Did I do that right? 5x and 6. Yeah, that's right. 4 and 3, 6 and 2. Oh, wait. Plus 1. Oh, this was on me, my fault. This should have been a 10. Because of that negative, the negative right over here. So be minus 2x minus 11. So this should have been a positive 10. And this should have been a minus 11. There we go. So now 1 minus 11 is going to give me a positive 10. Oh wait, that still doesn't work. Oh yeah, that's right. This should be a negative 10 minus 10. My fault. Okay, so let's redo this now. So I got the top part. All right, so I have an x and an x. So if I have negative 10, and I got to get to a positive 3, so that looks like it's going to be a positive 5 and a negative 2. So I have x minus 2, and I have x plus 5. All right, the x minus 2's cancel, and I'm left with x plus 5 over x plus 2. All right, and finally the last one. I got 2g squared minus g minus 15 all over 4g squared minus 25. I can factor both sides, right? I want to factor by grouping. So 2 times, let's do it over here. 2g squared minus g minus 15. 2 times a negative 15 is going to give me a negative 30. So I got 2g squared. Looks like it's going to be 6 and 5. So it's got to get to a negative 1g. So it's going to be a minus 6g plus 5g minus 15. Now factor by grouping. I'm going to take out the 2g, and I'm left with g minus 3. Then I'm going to factor over here. I'm taking out the plus 5, and I'm left with g minus 3. So now when I factor by grouping, I'm going to have 2g plus 5, right? 2g plus 5 times g minus 3. G minus 3. Now this is going to be over. Once I factor this out, those are both perfect squares. So I'm going to have a 2g and a 2g. Then I'm going to have a plus 5 minus 5. All right, so the 2g plus 5's cancel. And I'm left with, looks like, g minus 3 over 2g minus 5. And that is my answer. All right, guys, that's it.